Hello, seventh graders. The purpose of this video is to offer you some support as you are working through your Navigator session 12 that you have to do for our Friday assignment. So you could watch this video, you could pause it as you're working through to check your answers and make sure that you're getting the same things that I'm getting. And this is for you in case you might need some extra help. So we are working today on using what we've already learned about how to add and subtract with fractions to analyze and correct another student's work. So basically, you're going to be the teacher today, and you are going to look at another student's work and figure out if they've done it correctly or not. And if they've done it wrong, you're going to correct it. It is our Friday, so I want you to do our Gratitude Friday. I want you to think about one thing that you are grateful or thankful for today, and make sure you're putting that in your Pear Deck slides. So for our warm-up, we have a student that has tried this problem over here on the right-hand side. And the answer they said was 25, but I know that that's definitely wrong. Why can't the answer be 25? So what is wrong with the student's thinking? So as I'm looking through this, I know it can't be 25 because the two numbers that I'm adding are already bigger than 25 to begin with. And I'm supposed to add something in the 70s, and in the 50s, I know my answer is going to be way bigger than something in the 20s. So I know that the answer cannot be 25. So if I go ahead and start to try and think about how I would solve this, I know I would start by adding 9 and 4. And 9 and 4 is 13. I see that. 9 and 4 was 13, and the student put a 13 right there. And then 7 and 5, when I add 7 plus 5, it makes 12. And so that student put that down right there. And then they took the 13 and 12 and added it. I know if I do this problem correctly, 79 plus 54. I think what the student forgot to do is remember that we have to carry numbers up into the next place. So 9 and 4 is 13. The 3 comes down, but I carry my 1 over and jump it into the tens place. Because once I have more than one digit here, I have to carry it over. Now I have a 7 plus 5, which made 12, but one more would make 13. And it doesn't go below. It comes right next to this, and there's no extra number to carry over, so I'm going to write the whole 13 down. So my final answer was 133. So I think this student definitely did something wrong, right? What they've forgotten to do is deal with the fact that we have a carried number that has to come up. So you're going to go ahead and write your responses in. You can pause this video and then come back when you're ready. Okay, so that is kind of what we are working on today, where you're going to be looking at another student's work. You're going to try and figure out what they were doing, how they were working through those problems in order to get there. So we have this one. We have a student who calculated this problem. They got the answer of 2/12. I want to know, why can't the answer be 2/12, and what is wrong with the student's thinking? So if I look at this, I see two fractions that already had common denominators. I didn't have to do an LCM because the 6 were already 6. And so then they tried to subtract, and I think they subtracted on the top 3 minus 1 and got 2. But on the bottom, it looks like they did something wrong here. Instead of keeping this as a 6, they added their denominators together. So I think the correct answer should have been 2 6. And the mistake that the student is making is that they added their denominators instead of keeping their denominators the same. So you could write a response and then move on to the next problem. Okay, for this one, we have a student that has tried 1/2 plus 1/3 and gotten 2/5. So when I try and solve this problem, I see two fractions with different denominators. So I'm going to go ahead and do an LCM to try and figure out what my common denominator choice should be. So I'm dealing with 2 and 3. 2's go 2, 4, 6. 3's go 3, 6, 9. I see something in common. My 6's are in common. And so I'm going to choose that as my common denominator number. Bring those in for my denominators. And then I'm going to think about what I have to multiply by. So on the 2 side, it's in the third position. So this is times 3. What I do to the bottom, I'm going to do to the top. 1 times 3 is 3. So the first fraction should have been 3/6. On the 3 side, it's in the 6 is in the second position, so times 2. What I do to the bottom, I do to the top, and 1 times 2 is 2. Now that I have common denominators, I've changed my numerators, I'm ready to go ahead and add. So 3/6 plus 2/6 is going to make 5/6 stay 6. So 5/6 should have been my answer. So I know the student did it wrong. When I look at what this student did, the 1/2 plus 1/3 to get 2/5, I think what they're doing is they're just going straight across. 1 plus 1 would have made 2, and 2 plus 3 would have made 5. And so they're just adding straight across without getting common denominators. So you could give me a sentence or two about what the student did wrong with their thinking, and then correct it with that correct answer. All right, for problem 3, we have Mrs. Chi who has 3/4 of a cup of milk to use in a muffin recipe, and the recipe calls for 1/3 of a cup of milk. Does she have enough milk to follow the muffin recipe? And if not, how much more milk does she need? And if so, how much milk will she have left? And so this student said we would do 3/4. That's the amount of cups of milk that she has, and minus the 1/3, which is what the recipe needs. I agree with that. That's set up correctly. And then the student said the answer would be 2/12. And I see a problem right off the bat, because they haven't shown any work to get to common denominators, and it looks to me like they're subtracting straight across on the top, 3 minus 1 to get 2, and that maybe they're trying to do some sort of common denominators down here on the bottom, or they've multiplied the 4 times 3 to get 12. So I'm going to go ahead and solve it the correct way to check to make sure that I have an answer that makes sense. So I'm going to do an LCM with 4 and 3 because I don't have my common denominators yet. So 4s go 4, 8, 12. 3s go 3, 6, 9, 12. And I see that 12 is my common denominator. So I'm going to rename these fractions with 12s in the bottom. I'm going to come over here since I have some room. Then I'm going to worry about my next step, which is figuring out what my numerators need to be. So in the 4 side, the 12 is in the third position, so that's going to be times 3 on both the top and bottom. So 3 times 3 makes a 9. So the first one is 9/12. The second one, the 3 is in the fourth position, so that's times 4. What I do to the bottom, I'm going to do to the top. 1 times 4 makes 4/12. So I have 9/12 minus 4/12. Now that I have common denominators, I can go ahead and start my subtraction. So 9/12 minus 4/12, 9 minus 4 makes 5, and the 12s are going to stay 12s. This would be how much milk is remaining, how much she has left over, because we took the amount that she had and we subtracted the amount that she needed for her recipe. Okay, so make sure that you have some good information on your slide about what the student did wrong and what the correct answer should be. All right, our problem number 4, we have Anna, who bought 7/8 a pound of apples, and Tran, who bought 1/4 of a pound of apples. How much more did Anna buy? So I think there's a problem right off the bat with the operation that they chose. When they're talking about how much more Anna bought, that's really a subtraction problem, even though it says the word more. I'm trying to compare how much bigger 7/8 is than 1/4. So right off the bat, this person chose the wrong operation. They added instead of subtracting. And then it looks to me like they're also trying to do something with flipping this fraction over. which is something that we do when we're dividing with fractions. It's called the reciprocal. So they're also having some sort of an issue going on with knowing what operation to use, and then thinking about kind of confusing this idea of dividing fractions with what we do with adding and subtracting. So I'm going to go ahead and solve this 7/8 minus 1/4. First, I need an LCM in order to find my correct denominators. So I'm going to do an LCM of 8 and 4. And it won't take much work because I know that the next 4 is 8. So I see my LCM is 8. Then I'm going to think about, these are my denominators. What do I have to multiply by in order to get my numerators? So in my numerators, on the 8 side, it's in the first position. It's times 1. It's not going to change its value. It's still going to be 7/8. On the other side, it's in the second position. So it's going to be times 2. What I do to the bottom, I do to the top. So 1 times 2 would be 2. So 7/8 minus 2/8. Now that I have my common denominators, 8 stay 8s. So I would get 5/8 as a correct answer. Again, the student missed the operation, had addition instead of subtraction, and then is doing something that's confusing the idea that we have this reciprocal and we flip fractions over when we're dividing with what we do when we're adding. Okay, our last problem before our reflection is to show me at least 2 common denominators that you could use to calculate this problem. So if I'm trying to think about an LCM and finding common denominators when I have fourths and sixths, I'm going to go ahead and start my LCM chart, and I'm going to figure out what's the first thing that they have in common. So if I do my 4s, 4, 8, 16, 20, 24, and that would keep going. Oh, I missed one. 4, 8, 12. My 6s go 6, 12, 18, 24, and so on. So if I need a common denominator, right here, the 12s is actually the first thing that I see that they have in common. So if they ask for a choice for a common denominator, I know 12 would be my first choice because it's the first thing that they have in common. But if I continue looking throughout my charts and trying to find the next thing they have in common, they also both have a 24. So 24s could be used for a common denominator choice as well, because those are common multiples of both 6 and 4. You would just have bigger numbers that you would need to multiply by in order to change your numerators. But both of these choices could work for your fractions. When you go with the least common multiple, then you have a little bit less work to do in terms of simplifying your answer when you're finished. You could extend this table further and find the next one and the next one that they have in common. There will be many, many that they have in common. All right, so finally you have your reflection. So adding or subtracting fractions is easier if you do what? Is it easier if you write out your work and show your steps? If you are using the LCM chart? If you are drawing pictures? Are you a visual person that likes working with models? What makes adding and subtracting fractions easier for you? Okay, hopefully this video was helpful for you. Make sure that you get all of your slides finished, check your answers, and get this turned into Google Classroom for today.